Okay, so for target 4F, we are going to use our log properties. So for the first one, we are looking at our log properties, and this is one where when you have the same base, you're ending up with just the exponent. So right here, we have the same base of the 4, and so that means my answer is just 21. Number 2 could be done very similarly if I recognize that 81 can be rewritten as 3 to the something, and then put the 12. And so the reason I chose 3 is because the base is 3, and so then I want to have the same base. So if I look at my powers, I see it right here. I see an 81, and I see that I can write it as 3 to the 4th. So I can rewrite this as 3 to the 4th. And then I know that I have this property of exponents. So I know I can rewrite this portion as 3 to the 48. And so then I have log base 3 of 3 to the 48. And since these are the same, then I know that my answer is just 48. For number 3, I can rewrite natural log, ln, as log base e. And then again, I have the same base. So that's really nice. And so then my answer is just negative 32. Notice I'm making it really clear what my answer is. And finally, for this one, I can remember this property that my denominator of a rational exponent tells me what kind of root I'm taking, or my index. And so I can change it from here to that. So I can say this is really log base e of e to the 36 over 3. And so since these are the same, that's my answer. So my answer is just 12, because 36 divided by 3 is 12. Now again, when it says use log properties to condense, I will go back to my properties and look at the ones that put things together. So when I'm adding logs that have the same base, then I can condense them down by multiplying the m times n in my argument. And when I'm subtracting logs that have the same base, I can divide the arguments. So coming back here, I also have this property of when I have a number in front of a log that's being multiplied, I can put it over here and make it an exponent. So I'm going to use all of that. So first of all, I can move this 8 up to the exponent here of x. So I have log base 3 of x to the 8th, and then log base 3 of 7 minus log base 3 of m. So they're all log base 3, so I can put together the x to the 8, the 7, and the m, but I have to notice that x to the 8 and 7 are being multiplied, and then the m is being divided. But I still need a log because I'm condensing it into one log. So that is log base 3 of this whole thing, which you could also rewrite as 7x to the 8th, just because that's mathematical convention, but either one is correct to write the number before the variable. Now I'm doing the same thing, but I'm expanding it into several logs, and I need to do it fully. So I can say this is log base 2 of 5 plus log base 2 of a to the 3rd, because when I multiply, that's addition, and then minus all of this if there was multiple things down here, I would have to subtract all of it, log base 2 of w to the 4th. And so then I can say log base 2 of 5 plus 3 log base 2 of A minus 4 log base 2 of W. And that is my final answer. So that's for F.